Okay, so substitution was the first easiest order of business for determining a limit, okay? It is by far the one that you're probably not going to see more often than not, but it is the first order of business, okay? So what we have is, regardless of the function you're asked to evaluate the limit of, you'll still go with substitution, okay? From the very beginning, okay? If the substitution reveals a 0 over 0, that's what we call an indeterminate form. You can't make indeterminate, implying you can't make any judgment call as to the limit there, okay? So we look at this particular function, all right? The limit as x goes to 1 of x squared minus 1 over x minus 1, okay? Obviously, the limits are going to be asked at a point of interest. A 1, as you can see in the denominator, gives us a 0. But that does not imply necessarily that there's an asymptote, particularly when 1 is put in the numerator and also gives you 0. So the evaluation of this function at the value of 1 yields us something called the indeterminate form, which, as you can see, is 0 over 0. But that really tells us that's good, because then we go to it. Then we have another plan of action. That implies in almost every case that what you're going to be able to do is factor the numerator and the denominator and see a cancellation. So that's what we're going to do, okay? So indeterminate form arises from the occasions when a substitution yields a 0 over 0, which, okay, that's fine. It tells us you got more work to do. The first line of work you have to do is factor. So here we go. We factor the numerator. As you can see, x minus 1, x plus 1 is what it factors to. And then we cancel out the x minus 1, which means that this function collapses to x plus 1 with the provision that x is still not defined at 1. So the cancellation does not change the fact that from the very beginning, x cannot equal 1, okay? So that condition must be maintained. However, I'm not asking what is the function at 1, I'm asking what is the limit as we approach 1. So having done that cancellation, it allows us to very simply go through substitution and come up with this as the limit of 2, okay? So there's where you see the limit is 2, all right? So that's the first order of business when substitution yields a 0 over 0 is the factor, okay? So that substitution will work then. So in other words, this function is nothing more than a line, the line x plus 1, where there's a hole at 1, 2. 1 comma 2, there's a hole in the function, okay? So it does not say that the limit doesn't exist at that. The limit very much exists at that, and is 2. But it is a hole in the function. It's what we call a discontinuity in the function, okay? It's a discontinuity. That means the function is discontinuous at that precise value of 1, x equals 1, or the point 1, 2, okay? There's another type of evaluation that could result in the indeterminate form, okay? Here is one here. The limit as x approaches 0 of 9 plus x minus 3 over x, okay? Obviously, direct substitution of 0 into the expression will yield us 0 over 0, okay? Because you got the square root of 9 minus 3, it's 3 minus 3 over 0. So that's good. Once you hit the indeterminate form, it means you have to resort to plan B. Now, okay, there's really nothing to factor here, but what we do is we do a rationalizing. Okay, we have, if you'll remember, in algebra terms that are called conjugates. Conjugates, okay? So conjugate is the same, sorry about that, is the same expression with the sign connecting your terms altered. So the conjugate here is the radical 9 plus x plus 3 over itself. So in effect, we're multiplying by 1. Multiplying by 1 has no change to the function. It just changes its appearance, which will make evaluating the limit that much easier, okay? So the conjugate of the numerator is the same expression, okay? If our expression is a minus b, our conjugate is a plus b. The reason we do that is because we'll take advantage of the binomial pattern a plus b, a minus b, going to a squared minus b squared, as you can see here, okay? Which then yields a simple x in the numerator, okay? And the expression in the denominator was the x times, okay, that conjugate term. However, we've got our x's canceling out here, so the expression collapses to 1 over the square root of 9 plus x plus 3, which now can be evaluated for the x value of 0, okay, which means that now the limit can be taken by substitution method. So, okay, we have there an alternate form for the indeterminate form. If the indeterminate form, which is of course that which results by substituting, giving a 0 over 0, if the indeterminate form is not factorable, then it's likely to be something with which we have to rationalize, as we see here, taking advantage of what we call the conjugate. And conjugates are two expressions of the form a plus b and a minus b. Multiplying by the conjugate over itself, okay, and taking advantage of the algebra takes us out of the indeterminate form and leaves us in with an expression which we can evaluate the limit by simple substitution. We'll terminate this video here and come back and talk about some other tactical approaches for solving limits in the next video.